Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today we will examine bronze casting methods with a focus on the lost wax technique as practiced in ancient societies and adapted in modern foundries. I want us to think about the lost wax technique not as a single fixed recipe, but as a family of procedures that share a common logic. That logic begins with a wax model which is converted into a cavity and then filled with molten bronze. Let us run through the typical sequence. First, the sculptor models the form in wax. For hollow objects, the artist builds a clay or refractory core to set the interior volume. Then they attach a network of wax rods called sprues, which will later form channels for the metal to enter and for gases to escape. Next comes investment. The wax assembly is coated with successive layers of a refractory slurry and particulate until a robust shell is formed. In ancient contexts, the coating might have been clay and organic timber. In many modern practices, the coating is a ceramic shell built from specialized refractories. The assembly then undergoes burnout. The piece is heated to melt and evacuate the wax. This step is crucial because the wax leaves a precise cavity. The furnace temperature must be carefully controlled to avoid cracking the investment and to assure complete wax removal. After burnout, the foundry pours molten bronze. Bronze is primarily copper with about 10% tin in many traditional alloys. Some foundries vary the alloy to adjust fluidity and shrinkage. Control of pouring temperature and speed affects whether the metal fills fine details or produces defects such as porosity or cold shuts. Once cooled, the investment is removed and the cast is chased. Chasing includes cutting away sprues, welding pieces when necessary, refining surfaces with files and chisels, and applying patina. For large works, joinery and internal armatures may be added after casting. Historically, many great bronze sculptures were produced with versions of lost wax. For example, ancient Greek bronzes often used a core supported by chaplets to hold the core in place and a relatively thin wax layer to create a hollow cast. The Benin bronzes of West Africa are another striking example of artisanal lost wax work used to make detailed plaques and figures. The ancient process relied on locally available materials and craftsmanship. The core materials, the composition of the investment, and the alloy formulas varied by region and period. Those variations influenced surface texture and long-term conservation issues. In the 20th and 21st centuries, the lost wax technique evolved with new materials and mechanized steps. Ceramic shell investment replaced many traditional coatings in professional foundries because it combines thin but strong shells with excellent detail reproduction. Modern foundries favor the ceramic shell method because it yields finer surface detail and allows for consistent repeat casting. For small complex objects, foundries may use vacuum assist or inert gas environments when pouring to reduce gas porosity and improve metal flow into thin sections. For other cases, centrifugal casting is employed, where rotation forces the metal into the cavity, especially useful for small to medium-sized pieces. Practical considerations matter. The artist and the technician must allow for metal shrinkage, plan a gating system to avoid turbulence, and decide whether to cast in sections that will be welded together or in one piece. These decisions change how the wax model is made and how cores are supported. We should also consider failure modes. Porosity, misruns where metal fails to reach thin extremities, and investment cracking are common problems. Many of these can be mitigated by alloy choice, pouring temperature, vent design, and investment quality. Finally, the intersection of tradition and innovation is where contemporary sculpture thrives. Artists may choose the lost wax technique because it allows a direct translation of surface detail from the modeled original. Foundries continue to refine casting methods to meet artistic intent while increasing reliability and reducing waste. That overview covers the main procedural stages, some historical examples, modern technical improvements, and the practical concerns that sculptors and foundry workers must balance when using the lost wax approach to cast bronze.
Listen again to part of the lecture, then answer the question.
Modern foundries favor the ceramic shell method because it yields finer surface detail and allows for consistent repeat casting.
This concludes the listening section. For more TOEFL practice tests and study materials, visit spinta.org.